All right, well, we will continue our review today, and I think tonight we've got scheduled a review session, so we'll just get as far as we can. The final exam is cumulative, but it will emphasize the material since the last test, and we started the review last time, so this is review number 2. And I think the last one that we did was the relational database material, right?
Yes.
So I think the next thing is to review big O, big omega, and big theta, right? And so, actually, I guess I should have the definitions up here. So let me put that up. So let's review what that is. So here it is. Growth of functions. So you remember definition of an asymptotic upper bound. The upper bound is big O, so O for over, so that's the upper bound. And what it is there exists a C and an N naught such that the function is what? Less than or greater than C times G of N? The function is less than, because less than the overbound. The function that you're computing, it has to be less than the bound. And then the definition of asymptotic lower bound, big omega, is that the function is, yeah, okay? And then the definition of big theta is that it's both big O and big omega, right? So those are the definitions. And then we had a theorem here. We had some theorems about reflexivity and symmetry and transpose symmetry and transitivity, which are, these are some algebraic or some logical properties of big O and big omega and big theta. Let me see. And then we had this G.11, which dealt with polynomials. Okay, so let's go to our homework assignment, which is supplementary exercise S.27. So get out a piece of paper and a pencil and prove that, without looking at your past homeworks, prove that 5n cubed plus 10 to the 6th n squared plus 100 equals big theta of n cubed. All right? Can you do that? And this is without using, what was it, G.11? On all of these, remember. That it's illegal to use G.11. I mean, you could just quote G.11 and you'd be done. Because what we have is an asymptotically positive polynomial here. But we want you to prove it using the definition. All right, prove from the definition. So how would you prove that? What do you got to prove to show that it's big theta? You got to prove that it's big O and big omega. So, all right. So remember how to set that up? Yes, you must show that there exists a positive C and N naught. There exists positive C and N naught such that what? So I think you have to show that for the big O, you show that there exists positive C and N naught such that what? 5n cubed plus 10 to the 6th n squared plus 100 is what? Less than or equal to C times n cubed for n greater than or equal to n naught. Right? And then we start with this, right? And we do a number of steps, and in the steps we have either equals or less than or equal to, and we end. So we have a bunch of steps: equals, less than or equal, equals, in whatever order, and we finally get down to C times n cubed. And in the process of doing this, we come up with actual values for C and n naught, right? So how does that?
Well, first you could,
Yeah, to make this less, that we start with this side, 5n cubed plus 10 to the 6th n squared plus 100. We start with this side. We get that equal, less than or equal to equal, either less, I mean, in whatever order, a bunch of these. And finally we get it to this. So therefore we've shown that this is less than or equal to this.
do you want us to have it now together?
Well, no, you can do it. Can you do it?
I think I already did.
Are there any questions about how to do this? Are we working this out our own? Now on this one, can we just drop this? I think if we multiply this one times an n, oh no.
We can make it,
We can just, is this the one where we can just drop this?
well, you have to
This
change
is
it
less
for
than
next
or
year.
equal to, no, we can't just drop this. We have to make this, we have to get an expression to make this bigger so that this will be less than or equal to this, right? I think we have to multiply,
And by a lot.
I think if we multiply this term by n, as long as n is greater than or equal to 1, this will be, is that the technique that we used on this? The first step would be something like this, right? This is less than or equal to 5n cubed plus 10 to the 6th n cubed plus 100, right? Now, because we're making this bigger, so this is less than or equal to this.
But can't we just make the 100 and cubed too?
Yeah, I was going to do that in the next step. So this is provided, oh wait, well yeah, n cubed. This is provided, what, n
And greater than
is greater than or equal to 1. As long as n is greater than or equal to 1, then this is less than or equal to this, right? Because we're multiplying this 100, we're multiplying it by something that's bigger than 1, right? Yeah, I think that's the first step. Yeah? And then do some math, combine those, figure out what the c is and the n. Are we good? Okay. Any questions about that? All right. So now that was the big O. So now how do we do the big omega? To do the big omega, we have to show that this is greater than or equal to cn cubed. So now this is harder, right? Because we start with 5n cubed. Oh no, this isn't harder. Plus 10 to the 6th n squared plus 100. Now I think this is greater than or equal to what? 5n cubed, right? Now this isn't a provided, this is a because. Are you with me? Because we know that this is positive and this is positive, right? Because 10 to the 6th n squared plus 100 is positive. So if you drop a positive quantity from this is greater than or equal to this. Because yeah. So any n will do. Any positive n will do. And then this equals provided c is 5.
So do you just pick an n, or do you say n greater than 0? Or n greater than or equal to 0?
You have to pick one.
Okay, so n equal.
Yeah, and the one we always pick is 1. Yeah. Is everybody good on this? Now the next one is trickier. Okay, supplementary exercise S.28. Okay, it says prove that n cubed minus 9n minus 50 is big theta of n cubed. So See if you can do that. I'll let you try that for a few minutes. Okay, so yeah, sounds like we need a little help here. So it's n cubed. Okay, so what we have is n cubed minus 9n minus 50.
No, it's not provided it's because they're negative. So like, you know, that happens.
So is the hard part the big omega or the big big O? Big O or big omega?
On big O, can we just drop it, provided n is greater than or equal to 1?
Okay, let's think about that. So for big O,
That's negative for
so for big O of n cubed, to show the big O, we have to show that this is less than or equal to c times n cubed, right? Is that right?
Is n always positive, or do we have to provide?
No, hold on. N, what you have to provide is n0. You have to show that, yeah, let's review, maybe we should say this once. Here's what, you must show positive c and n naught. Are you with me? Such that n cubed minus 9n minus 50 is less than or equal to c times n cubed for n greater than or equal to n naught. So this n is the variable, c and n naught are the constants, and the c and the n naught, the constants, have to be positive. So
It
that,
can't even be 0. It has to be positive.
exactly. Yes.
So this isn't a
It
provided,
can't-
it's because.
Well, this is what we have to prove to show that it's big O. This is what we must come up with. We must derive a positive c and an n naught such that this is less than or equal to this. So we have to prove that there exist these two constants such that this is true for all n greater than or equal to n naught. So what you do is, we start here. Now how does this one work? Can you, on this one, can you just drop this? Oh yeah, because this is negative. Okay, so for this one you can just say this is less than or equal to because negative 9n minus 50 is negative. You can just make that be n cubed. And then, so this equals, provided c equals 1. C times n cubed, right? So therefore, and so any n naught will do, right? So c equals 1 and naught equals 1. That's the easy one. Okay? Okay, so that one was easy. That was the easy one. The hard one is this. How do we show that this is big omega? So the way you show that this is big omega, we must show positive c and n naught such that n cubed minus 9n minus 50 is greater than or equal to c times n naught for n greater than or equal to n naught. Now this is harder because what we have to do is we have to get this to be greater than or equal to something, right?
If you multiply by n, doesn't it just make it more negative then? So wouldn't that be?
Yeah, we can stick an n on here, and because this is negative, we would be making it more negative. So this would be greater than or equal to that, right? So this is greater than or equal to. Are we claiming that this is greater than or equal to n cubed minus 9n minus 50n?
Sure. Could you make it the n cubed too?
Well, I don't think you would want to make this n cubed because then you'd have an n cubed minus n cubed, and then you'd have a negative coefficient out there, and I think that would.
That was the technique.
Yeah. So I think the thing to do is to make this, is to get this up to be the same degree as this, because this is a negative, right?
What's your hint on that? Or what's your,
And yeah, so now what is the hint? This is,
provided?
Yeah, actually, this has to be provided n is greater than
Or equal to 1.
1, yes, right? Because if n is less than 1, like if n is a half, then it's not true, right? Are you with me? Then it's not, are you with me? So this is the only way you can do this is provided what?
N is greater than or equal to 1.
Provided n is greater than or equal to 1. Yeah? So now this 1 is where we're going to get our n naught if everything works out. Oh, maybe, well, we'll see.
It's the C.
Okay, so now this equals by math what? Okay, so now I'll let you carry on. So this equals by math what? N cubed minus 59n.
And then you bring in
Now, then what I would do is on the next step, factor out an n. So then what will you have?
and then
So equals by math what?
n times n squared minus 59.
N times the quantity what? N squared minus 59.
And then you have to do that trick.
Now here comes the trick. C can be positive. I'm sorry, C must be positive, but it's okay to have it be like less than 1. Right? So what I would do is I would make it be a half.
Oh, yeah, that's the only way it would work. I was like, how is this going to work?
Yeah,
That makes sense.
yeah.
How do you pick what you're going to make it the C whenever
You know what? That's a good question. The question was, how do you know what to pick for C? And the answer is, any fraction will actually work. Only difference is, if you have one C, you're going to get a different n naught.
Right.
See, there's more than one pair that will make this true. You can come up, all you need to show is the existence of a C and an n naught. And if you come up with a different C and a different n naught, but it's still true, then you've proved it. So you could actually have C be a third if you wanted, or
Because on supplementary exercise 29, like I had to go through 2 or 3 different C's because it was negative. If you did like 0.5, it was -1. If you did 0.25, it was like it was 0.
yeah, you know what? I remember your solution to S.29, and you didn't actually have to do it. It was correct, but you actually didn't have to use that technique. In fact, I was surprised to see that technique used on that problem. But it was valid. You had a valid argument. I remember that. But you actually don't need to use that technique, because where you really have to use that technique is if you have negatives
Okay.
here, and you didn't have that there. But it worked, and I thought, oh, well, that's quite inventive, because I remember having to go through that. No one had ever done it that way before. But it was a valid proof. It was yeah, I remember that. All right, so are you good? Is everybody with me here? So what you should have down here eventually, boom, 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 is you have a, so what do you have? You have an n and a what?
N squared minus 59.
N squared minus 59. Now what you can claim is that this is greater than or equal to what? What can you claim? What do you want to claim? This is greater than or equal to what? N times what?
Half N squared.
Times a half n squared. This is the step. This is the crucial step. You want to claim that this is greater than or equal to n times a half n squared. Now, how can you claim that this is greater than or equal to this? The only way you can claim that this is greater than or equal to this is if what? Is if n squared minus 59 is what?
Greater than 8.
Greater than or equal to a half n squared. Are you with me? Okay, so that's what you put in your hint. In your hint you say, okay, so what do you say in your hint? Provided that,
Half N squared is greater than or equal. No, N squared minus 59 is greater than. No?
Yeah,
It's not greater than N or half N squared.
yes, n squared minus 59 is greater than or equal to a half n squared. Then inside your hint, after you say that, then comma, and do a little math on that. So if you do a little math on that, what will you have inside your hint?
N equals square root of
N squared minus 59 is greater than or equal to half n squared, so take the half to the one side. Subtract half n squared from both sides and then add 59. Are you with me? So do that inside the hint. And what do you get?
square root of 118.
Well, what about square root of 118?
That's what n is.
No, it's not what n is.
What n can be.
No, it's not what n can be. It's what? You're solving an inequality. What do you have? What do you wind up with?
N is greater than or equal to.
N is greater than or equal to.
I would pick just 11, because that's like radical, what, 121?
20 something.
So it's just
Well, yeah, n, yeah. Oh, you'd round up.
to 11.
Yeah. But anyway, so what you have, so in the hint you have provided that n is greater than or equal to the square root of 118. So that proves, you have proved, and you have shown that as long as n is greater than that, then this is greater than all this, right? And so there, and then, so your C turns out to be a half, and your n naught turns out to be the square root of 118. And you could do the ceiling of that if you want, which is 11. Is that what you said? The ceiling of 100.
That's what they call it? The ceiling?
Yeah, do you know? Yeah, oh, yeah, you should know this. This is, yeah, okay, so, yeah, like 11.5. There's two. This is called the ceiling. It's like this. And the ceiling of 11.5 is 12, right? And the floor of 11.5 is 11. So the ceiling is round up to the nearest integer, and the floor is round down to the nearest integer. And this is the symbol for it. I don't think we use these symbols in this course because we don't deal with real numbers very much. This is all discrete structures, and so everything is integer, you know.
Yeah.
But, you know, just in general, this is the ceiling, this is the floor. It's round up and round down. Okay, are we good? Now, how about supplementary exercise S.29? By the way, I have a comment. I remember grading these. I think some people didn't actually graph their things very accurately. I challenge you to graph f of n equals log n over the range 0.25 to 5. Can you do that? So this is 0, this is 1, this is negative 1. This is n. Do that. Graph. First of all, what's the graph of f of n equals n? What does that graph look like?
Aren't you higher up on your...
Up, yeah, okay. So that goes through 0, 0, right? Is that right?
Yes.
So, and then it goes through 1, 1, and then 2, 2, right? So it's like this. Okay, so this is f of n equals 1. But what does f of n equals log n? Log base 2 of n.
It does.
Yeah, it goes through here. And then what? It goes through 2, 1. So it goes through here, and it goes through 4, 2. And most people got this one right, but where people messed up was what happens in here?
It goes straight down.
Well, what do you mean straight down?
No, like it goes.
Okay, so what is it at a half?
It's 0.1. Or wait, is it 1? -1.
At a half, it's -1. And at a fourth, what is it?
Negative,
See, some people had it hitting this.
-2.
Well, it isn't asymptotic.
Wait, a fourth, yeah, is -2. Is that right?
I think so.
Would we have to do this on the test?
And an eighth is -3.
And an eighth is -3. So it's like this. Some people had it hitting this.
Right.
It can't. It's that. You're right.
And 0 is in.
So we just did that. We just did that one. Some people didn't get all the way down to -2 here. Anyway. So for what values of n is log n greater than 0? This is log n, right? And LG is log base 2. So for what values of n is log n greater than 0? For n greater than 1. So it's, yeah. And for what values of n is,
And greater than-
for what value of n is log n greater than 0? That's 1, yeah? For what values of n is log n greater than 1?
2.
And 2, right? And then for what values of n is n greater than log n? And all values greater than 0. Yeah? And now prove that 2n squared times 2 to the n plus n log n equals big theta of n squared 2 to the n. All right, so how do we do that? Well, we got to do big O, and now I think on one of these you can just, oh wait, or can you drop? What's the one where
You can drop it, but that's not.
you can drop, what's the easy one? The easy one is where you can drop the n log n, as long as n log n is positive, right?
Then that is, and that's going to be
As long as n is greater than 1, you can drop, provided n is greater than 1, you can, wait. Which one is easy, the big O or the big omega? Okay, so are you guys doing this? You working it? I think the big O is the hard one, right? With big omega, is that what we said? With big omega, you can just drop the n log n,
provided n greater than or equal to 1.
provided n is greater than or equal to 1. You can just drop that. So then right. So the big omega is the easy one.
For big O, don't you use Pradina?
Well, I mean, even for the big omega, you have to, in order to drop n log n, you have to note that n times log n is greater than, is positive only if n is greater than 1. So you still have to, right?
Yeah.
Because if n is less than 1, then this is negative times a positive, and you'd be getting a negative.
Negative fraction.
You'd be getting a negative. So even, I mean, you still have to use this even in the big omega case.
So whenever you're finding the next one, like where you're doing the less than or, can you do, whenever you apply part D, or can you do n squared and then do you do 2 raised to the n as well? Is that how you transform?
Okay, hold on. Okay, so what you'd have is you'd have 2n squared times 2 to the n plus n log n, and I'm claiming that this is greater than or equal to 2n squared times 2 to the n.
Oh, I'm sorry. I'm doing less than or equal to on the big O.
Okay, but let me just, as long as we're on film here, let me just do this. So this would be showing the big omega, and this would be provided provided n is greater than or equal to 1, provided this, n log n is positive, right? So if you drop a positive thing, then this has to be greater than or equal to this. Are you with me? So that's how you would do the big, so just dropping it, that's how you do the big omega. But now to do the big O, yeah, the big O is harder because you, so this has to be less than or equal to something. I claim that this is less than or equal to 2n squared, 2 to the n, plus
N squared 2 to the n.
n squared.
Dot. Why don't you just do the 2 to the n? That way you can just do 3n squared 2 to the n.
Well, let's just do because how do we go from here to here?
Because part B.
Yeah, how do we know that this, see, we have an n squared, we want to get this to match this n squared here. How do we know that this is less than or equal to this?
Because in part D, we know that n is greater than log n.
Because by part D, n is greater than, yeah, this, actually, we could do it like this. N times n, right? So this is this n. Okay, so provided so n
Oh, so you're just splitting what I want.
log n is less than n, which is true, right? For because, I guess this is because, right? By part D. Because log n is less than n by part D. Right? Are you with me on this? So we're replacing this by something that's bigger. So therefore this has to be less than or equal to this. And now you can just do, oh, I see what you're saying. In another step, you can multiply this times 2 to the n, because 2 to the n is positive. We didn't do a graph of that, but we know that because 2 to the n. And then you'll have 3n squared 2 to the n. Or sorry, 3.
Yes, that's exactly.
Yeah. Then you'll have 3, and then the c can be 3. Right. Okay, so Rochelle, do you see how this is a little bit easier than
Yeah,
what?
I just had 2 to the n instead of 3n squared. Yeah.
But yours worked, but I think this is easier. Okay, now I think a lot of people missed this exercise S30. Is 2 to the n plus 1 big O of 2 to the n? Now check this out, you guys. S.30a. I don't know if, I think I handed out the solution with the reason here, did I? But look at this. Look at this, you guys. Does everybody see that 2 to the n plus 1 is the same as 2 to the n times 2 to the 1? Are you with me on this? But that's equal to, conjunctive meaning of equals now. But that's equal to what? 2 times 2 to the n. Is everybody clear? And furthermore, look at this. Furthermore, this is a what? What is this 2? That's a what? That's a constant. Are you with me? That's just a constant. Are you with me? So what do you think? And here's this 2 to the n. So what do you think? Is 2 to the n big O?
Yes.
Yeah. Is it big omega? Yeah, because it's just a constants don't matter, okay? Multiplicative constants, yeah. So yeah. So the answer to A is yes. But look, what about B? But what about B? Is 2 to the 2n, big O of 2 to the n. Well, check this out. 2 to the 2n is 2 to the n times 2 to the n. Now, what's the problem? The problem is this is what? Not a constant. Right?
Correct.
So 2 to the 2n is not bounded above. So it's not. So the answer here is no.
It's bounded below.
On the other hand, is 2 to the 2n big O? I didn't ask this. Maybe I should have. Is 2 to the... Oh, I should change my... I should have A, B, C, D.
This was the
I should have, is this big O, is it big omega, is this big O, is this big omega? Because is 2 to the 2n big omega of 2 to the n?
Sort of like asking, is it a big theta?
It's not big O.
Is it big omega?
Is it big omega? However, what I claim, 2 to the 2n is big omega 2 to the n. In other words, it is bounded below. Well, for sure it's bounded below because it's...
Can you do 1?
Yeah. Actually, that's a good point. 2 to the 2n is also big omega of 1. Yeah.
Oh,
So put that in your pipe and smoke it. Which in a few days with our t-shirt, we'll be able to take off our shirts with our t-shirts on and turn around and say, so put that in your pipe and smoke it. So actually, for those of you guys who are out here, I'll probably, when you're watching this, I'll probably still have some t-shirts left over. We have a great Formal Methods black t-shirt with a proof of 8.22 change of dummy on the front. And then on the back, it says, so put that in your pipe and smoke it. So anyway, we just ordered those.
so 6 o'clock tonight?
Yeah, and so we'll see you at the review session tonight. Okay? Good deal.